Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter. We've we're on episode 11, so we've done a little bit of work, and we've done a lot of work around expressions. And last time, and the last few times, we've been working on control structures. Let's go back and do some more on expressions. They're kind of the big piece of the language. Let's see. So today we're going to look at variables. And in these old basics, a variable was very simple. It could either be a single letter, optionally followed by a digit, optionally followed by a dollar sign, which means it's a string. We haven't dealt with strings at all yet, so I don't know if we'll bother with the strings yet. But yeah, there's no long names or anything like that. There are other basics out there. The Commodore 64, I think you could have two letters. Actually, you could have arbitrarily many letters, but only two would be acknowledged or used, and you couldn't have a reserved word in the middle of your word. So renew would be a very bad word variable to use. Okay, and then the assignment statements. Originally, you had to have the keyword let. So let x equal 3 plus 2 was fine. Now, at least, by 20 years later, the let became optional and you just could do variable equals expression. So you, each line in BASIC starts with a keyword except now this let. So if it's not a keyword, it must be a variable and go from there. Also, we want to notice that we use equals for the assignment, but it's also a relational operator. So A equals B equals C, it uses it as a relational operator on the right. B equals C gives you a 1 or 0 and then assigns that to A. Okay. All right. Let's see. So expressions, variables, and I should show this picture every time probably. The big structure of an interpreter is it's like a compiler in the front half. It reads program text, it scans it or lexically analyzes it, produces a stream of tokens. So a variable will be a token even though it might have more than one character in it, and a keyword is a token, and so on. Then it goes to syntax analysis or parsing, and that produces a tree of nodes. And the nodes are things like there'll be an assignment node, and it'll assign a variable, a value to a variable. And the difference is an interpreter just takes those nodes and then does what the node says. It builds some context that I don't show here, but it keeps a map of the variables, it keeps a stack, it keeps other things, and uses that to interpret the tree of nodes. All right, so what that means is, well, we've got a grammar down here. Program goes to lines, there's statements, and then somewhere here we can print expressions. I think we've left out a couple things. Yeah, let's add the other statements we've done. Go to integer line number. I guess I should quote these to be consistent. And this style I'm writing is, it gets by various names, but Bacchus Nauer form, Bacchus normal form. It's not really a normal form, so that's not a great interpretation. But John Bacchus was one of the main people on the original Fortran compiler and developed this sort of grammar writing approach, and really got used in Algol when they got going with that. So the left-hand side is called a non-terminal because it expands to other things, and these quoted ones are terminals because they just represent themselves, and this is actually more or less a terminal as well. But we got a go-to statement, and then last time we did an if statement. If expression, then, and we just support the integer line number for now. So if expression, it's implicitly go to whatever line number. All right. And now we have our expressions. notice how many levels this is. It's because there's so many different precedence levels. Each level of precedence gets its own little rule. All right. But down here, factor is a number or an expression in parentheses. We want to say factor can be a variable. And the variable, this is more at the scanner level. A variable is a letter followed by an optional digit followed by an optional $sign. Okay. And then in terms of our program, what this means is we need to make the lexer support variable names and then make the parser allow variables as part of our expressions. Okay, so we're doing them on the right-hand side. At least Commodore 64 Basic, the default, if you use a variable without assigning it first, is to make it 0 or empty string, if it's a string variable. So we will do that, and so we can put them on our right-hand side, but we need to let the assignment statement to really get anything useful in the long time. All right, so our lexer, we have all the keywords, and then A to Z. Yeah, so we look for the digits starting a number, all the operators, including the ones that take multiple characters, and then the letters. And if it's a letter, we say, oh, it must be a keyword in name. And I added names because we were going to be doing names today. But keyword, okay, so what it does is it finds all the letters starting at the current index, and then it backs up. Let's see. I feel like there's something a little funny here. It backs up. Okay. So we pull out the possible letters, and then we check if any of these are in the reserved word list. And if they're not, well, we don't know what it is. If they are, and that's where we're going to be plugging in here. It's not a reserved word. It must be a variable. If it is a reserved word, we skip it, so we move forward over it. And, then there's some semantics that come in. Okay. Remark has ignore until end of line. A then statement, we have to manage looking for an integer. So that's that. Okay. And I can see we've got some opportunities, let's say. All right. So let's worry about this case. Answers nil, return token unrecognized name. Well, answer nil means it's not a reserved word. And we said, oh, variables, they're single letters followed by optional digit, followed by optional $sign. We don't match those yet. Okay. So let's put a test in that looks for it. Okay. And so these tests, well, let's go up to the top. You basically start the lexer with a string, and then you ask for the next token and see what it gets you. Okay. So we will do that. Okay. And this is more than we need, but I'll just copy it nonetheless. This is a single letter variable. Let's start easy. Variable. Okay, so let's just look at A. And token equals next. This should be a variable A. And we don't need this. Okay, so if you you start with, if you're looking at the string A and you ask for the next token, you should get this variable. Well, variable isn't in our list yet. So tokens, we define one for each kind of thing. Miscellaneous overheady things, the numbers, a bunch of operators, reserved words, and so on. I'm going to put the variable up here with the numbers. Okay, so variable, and we'll give it a string to know the variable name. Okay, and this test should fail. It'll probably come back with that error. Oh, I didn't say throws. They're going to complain, aren't they? No. Okay, well, I guess we return an error token. That's why. Okay, so we get unrecognized name, the code we saw, not equal to a variable. Okay, so we got some work to do over here. So if it's a letter, whoops, sorry, but it's not a keyword, it must be a variable of some sort. So let's return variable. Oh, I can probably extract this for now. Okay, and I tend to want them to go top down. So let's do that. All right. So handle variable. Well, we know that our start index is at a letter, because we started here. Okay, so let's capture what we've got. Var name equals nothing for now. Well, we can capture it. So it's really program subindex, and I don't know. We maybe want to wrap that up a little bit, but okay. So that's the starting point. All right, and instead of token.error, we want to do a token.variable. Variable with name. All right. I don't know if I can do this. I may have to. Yeah. Okay, and with any of this, we have to maintain the index. So we're consuming it, so we just skip past it now with index plus equals 1. All right. Yeah, we'll let it be for now. Okay. But that should make this pass. All right. And let's do a variable followed by a digit. I'm going to change this name. So test variable with single letter. Okay. And practically the same. Oof. And I don't know. I keep saying I'm going to put some parameterized testing in, and maybe I just have to bite the bullet and do that this week. This test is so similar to the last one, right? All we could say is you need the input and the output. Well, actually, if you knew the input, you should know what the output should be as well. Okay, so let's do Z9. and variable Z9. And this should fail because we don't look for digits. Okay. I'm going to extract this if I can. Extract method. Let's say is digit. Okay. We'll move that up. All right. But we're going to use it here. If the current character now is a digit, well, we're going to skip. Well, we're going to save it. And skip past it. And that should do it. Oh, same problem. I'm sure there's a better way to do this, but if you're a Swift person, definitely speak up. Okay, and let's do the $sign one while we're at it. Okay. And this is if program subindex equals $, then we're going to say name plus equals $, and index plus equals 1. Okay. Now we haven't worried about the types. Maybe we don't have enough to justify it yet, but at some point I would expect that we would understand the type of a variable as well. Maybe from its use, we should be able to tell that it's either numeric or string based on the name for sure. And then we have array types and matrix types as well. But I think we're okay for now. Let's find one more case. I'm trying to think of an error case for this. If it doesn't start with a digit, I mean, if it doesn't start with a letter, it won't come down this path at all. So it's not anything we're going to test here. If it's not a digit or a $, after that letter, we don't accept it. So if you put, I don't know, A equals X, Y, two separate words. Well, we squeeze out spaces so it looks like a long variable. The X gets parsed. The Y, when you get there, you're looking for an operator or a new line or parenthesis or something, and you'll say, "Oh, there's something missing." So, I don't think you can go wrong here. It'll show up at the next token, not this one. All right. So let's check that in. Lexer handles variables of letter plus optional digit plus optional $. And I guess notice the if statements, they're independent, so you can have a letter plus a digit and a $, or a letter and a $, or just a letter and a digit. They're all independent that way. All right, so that's the lexing. Now the parsing, I don't think it's going to be too bad, but we got parser All right, yeah, we're down in expression land. Let's find factor. Here's factor. Um, this case is the left parenthesis. This case is the number. This case is anything else. So right now we would get an error for a variable. All right. Let's refactor a tiny bit here. I think given this is already 3 clauses and we're going to make it 4, let's extract out this. So I'm just going to make a method for that. Handle parenthesized expression. I don't know if I'm liking this handle thing, but that's what I got. Oh, maybe I should just drop the word handled there. Yeah, that's better. And that's looking better, I think. Lumber. And this one is a number. I'll say numeric factor. All right. And make sure tests run. Let's run them all this time just for a change of pace. Oops. Okay. So much for that. Unexpected statement. What? Oh, interesting. That is correct. Let's see. Maybe our unexpected statement is, well, that's just not an error. Yeah, that's really not an error. I guess if you had that, it would think, oh, you got a variable W and followed by stuff, and I don't know what you're doing. Unrecognized name, and it's a token W. Yeah, I think this test is just obsolete, that we support W as a variable, and so the front of this thing looks perfectly legal at the moment. It could be an assignment that misses an equal sign or something. All right, I'm going to delete that. Okay, and let's push this. Okay. Let's go back to the Lexer and just make sure I didn't leave anything funny in keywords and names. Okay. Yeah, so now we know. It's kind of an awkward method. It's got this return out of the middle, but we know we got a reserved word if we get down here, and otherwise we do treat it as a variable. So there's no error messages down here. So, okay, that's what I wanted to check. All right, back to the parser. Let's see this test. Okay, the parser. So we're going to modify this so that there's another case that could happen, right? We added a third rule that says it could be a variable. All right. And let's find parser tests. Parser tests. And I want to get up where the expressions are. Okay, there we go. Okay, and so we can check expression. We give it a string. We'll let X mark the spot today. And then the expression we expect is, well, there's no operator. It's just a variable. And we have number, but we need a variable for this thing. Okay, so this is our parse tree. If it's unary minuses, it's unary operator minus, unary operator minus, unary operator minus, and then the value 21. Here it's just a value, which should be a variable. So let's look at parse. And expression has number, but we also need, variable. And string, at least for now. Should that be a token? I think just the variable string for now. All right, and we should fail. Well, not for that reason. Switch value must be okay. This is our interpreter. We have to say something. So case.number return -1. We'll just hard code junk. Oh, why can't I do this? Variable. All right. It failed. Extra characters at end is what our parser came up with because it doesn't handle that case yet. All right, let's make it handle it. Else. Okay, so, well, let's do the same thing. I don't know if I can make the class, the name the same. Let's try it. And we'll define a function. Well, we want to return junk, so let's just return numbers 0, number 9, 90. Okay. So this time I want to be, oh, what happened? Case variable. Two failures. Case.variable led. Sorry, just making sure. One test with 2 failures. I don't get it. Okay, I'm going to run all these again. With 2 failures. Unexpected statement. Well, that's weird. Let's run this. It doesn't even get there. Okay, so what's going on? What's the message? Characters at end. Skip is not equal to line 10. Hmm. Factor. Well, skip is what you get when something's not understood at all. And let's go and check expression, make sure it works the way I expect. Okay, so it puts 10 print and then the variable, which is expression that we plugged in, x, parser. Let's stop here. Wait, parser. Okay. Okay, that's just a bunch of setup. All right. Let's step in. Let's go this far. Line. Oh, okay. Okay, so we get to the line number. We try a statement. Let's step over, in. Yeah, I think. Okay. In our case, we have a print. Okay. And yep, there it is. Our print statement has to know what kind of thing it's got going. Otherwise, okay. If you've got the right thing, we get it. If not, we skip out. That's a little artificial. I think the default would be a new line at this point. Like if you could just say print and it just prints a blank line. But anyway, we know this thing has to accommodate expressions that start with variables. So these are they call it the first. What's the possible first tokens for the expression? Well, it has to be either number variable minus left parent or not, based on the operators and stuff we have. Okay, so what's bugging me is it would have been good to yeah, I think it would have been good to express what went wrong better. Let's add that to our list here. Okay, so make print more explicit about what's wrong. All right, and then back down to our test. I think this should be fine now. Tells you what I know. Okay, parser tests. Extra characters and scoop. Well, that sort of says we didn't get in this case yet. Oh, what is going on? Parser. Number variable. Okay, print statement goes in here. Expression. Let's just make sure our expressions on the way down, leftmost thing and expression, negation, relational, sub-expression, term, power, minus, note, factor, left paren, number, variable. Okay, I'm puzzled. I don't like being puzzled. Okay, so we know print. Let's go in print statement. We'll stop here. Token is a variable X. Okay, that's good. Step over. Okay, expression will go in. Now we're going to take ourselves down this chain of expression, term, power. Okay, our token is a variable. So left paren, no. Okay. Is it a number? No. Is it a variable? It better be. Okay. Return number 90. Work our way back up through all these operators. Okay, value should be a number now. Yeah, number 90. Okay, we append that. Number 90. Okay, I'm justified in being puzzled, I think. Okay, require end of line. Oh, did we not do next token on our variable? I guess I should just print token. Okay, haha. Oh boy. Because our variable didn't do anything. All right, normally you match something, you got to consume it. All right, so next token. So what happened is we parsed the variable, we returned 90, which was a, purposely wrong answer. We exited in our print statement. At the end of each statement, we check and make sure there's nothing else on the line. Well, there was, because we didn't do next token. There was still a variable sitting there. Okay. Okay, let's take these out. Oh, I'm still messed up. Oh my goodness. Hopefully it's number 90 is not equal to variable. Okay. Let's fix that. That we can do. Variable name. Excuse me. Yay. And this unexpected statement's still gone. I don't know why. If I open and close, does it? I don't know. But our existing test pass. Okay. So parse variable. All right, so we've gotten through 2/3 of this. We did the lexer, we did the parser. Now we need to do the interpreter. And I see it's time for a break. So let's take a 3-minute break. We'll come back and make our interpreter, when it sees a variable, return 0. Well, actually, it should try and look it up and return something, but we'll figure it out. Anyway, 3 minutes. See you then. All right, welcome back. Oh, I should say, I'm going to be late tomorrow morning. I'll probably be 45 minutes, probably an hour late. So just so you're aware, a late start tomorrow. And I'll say this again a couple times if I remember. Alrighty. We're ready to evaluate. We've flexed, we've parsed our variables. Let's evaluate them. And I don't know if we have. Well, we do stuff like print. Yeah, we can do that. Let's find a simple print. Yeah, that's more complicated than simple, but we can simplify. Okay, test variable defaults to 0. So if we print Y9 and we've never seen it before, we should get a 0 out. And we think this test will fail because we just hard-coded a -1. All right, and we can say they default to 0. Okay, now default to 0, this is, well, the reason they default to 0 is because the variable doesn't exist, but we don't have any variables at this point, right? That's state that we're missing. So, I don't know if the map. Well, let's add it. Var variables. And the type is string to float. How about numeric variables? I don't know. We're going to have to work something out. Okay. And it starts off with an empty map. All right. That's no change. All right. But where it matters here, our evaluate the variable, it's really numeric variables subname else 0. Okay, so my claim is this should pass the same. Yeah, if I can let name. That I refactored 0 to being a lookup. Okay. I don't know, this thing about strings, we probably shouldn't wait too long to address it because types are going to become an issue for this stuff. I don't know, maybe string variables should be a different thing. We'll have to figure that out. But all right. But in any case, we've added variables to expressions from lexing parse. for lexing part. Trust me, it's a word. Parsing and interpreter. We're interpreting. All right. Cool. Well, that, I think we've got that error we had still. Okay, so in a sense, this is done, but let's go back, and we had that print where we had something wrong. Now the problem was we didn't do our next token, but I think there's something deeper going on there. Okay, so, and our print statement, they're actually a relatively sophisticated piece of the language too. So it's hard to know. Let's find our tokens. Okay, so tokens the input. We should have an end of line at the end of our print. Okay, and that gets handled by statement here. Let's see. Statement, and then we require an end of line. Okay. But in here with the print, we're saying, what can you print? Well, right now you can print numeric expressions, and I think, let's see, I guess the case I want to trigger, let's print plus. And I think we'll see that it's not a very good error handler at this point. Okay, there's a print. Okay, and it's an error case, so that's good. Test print improper expression. Okay, so input equals 10 print plus, and the parser equals the parser, and the message, I would expect something to say like maybe unexpected element. Where's our errors? There and here. Unexpected. Well, expected start of expression would probably be accurate. Okay. Now that's going to fail because I don't even have it in my list yet. Oh, it is here, but we don't do it in the print. Okay. Is not equal to, extra characters at end. So we see the plus, we say, oh, you did your print and now there's stuff at the end. But really the problem is when you come in, it's like we know this is a problem before we get to the end of the line. It really is in the print. I think this is case end of line is break, but the default should probably be this parse error. Parse error dot expected start of expression. Okay. And dot. Parse error. What do we do? Are we throwing? We're throwing. Okay. So. Yeah. Okay, now let's take this off, run our tests, and make sure that the error we see kind of leads us to it. Okay, so parser test, print is error. Whoops. Print. Okay. Expected start of expression. Right. Okay. What about this one? Yeah, that's the one I was worried about. Test variable. Expected start of expression instead of this nothing. Okay. Expected start of expression. I think that would take us there. The skip, I don't know, is basically because we don't, we just return skip when you throw an exception. So normally you wouldn't, the parse is invalid, so you don't really look at it. Okay. Good. Now I've got to put that back. Okay. So, throw better error when print doesn't have proper expressions. Okay. Yeah. So I think I would say that's done. Both these. And this is 11. Okay. And now we want to do let. All right. So what's going to make let tricky? Well, let's see. Let's go to our grammar. And you lean on the grammar quite a bit. I mean, that's one of the lessons that they really learned in the 60s and 70s, like how much you can lean on the parsing and the grammar. You know, you can lean on the grammar to get your parser and drive things off these trees. You know, that really became a kind of standard thing really in the 60s, I think. Okay, so where's my statements? Print if go to. All right, we didn't actually define it, did we? Okay, so we have a new statement. It goes to optional let, and then variable equals expression. And this probably I should capitalize. I'm kind of trying to capitalize the tokens, I guess. Which sort of means I don't need the quotes here, I guess. But yeah, let me just start taking those out. I don't know, I'm kind of mixing my syntaxes. But let variable equals expression. So we can look for a let, but the real thing is variable equals expression. So let's start there. All right. Do we need any tokens? Well, no. We have the let, we have a variable, we have equals, we have expression. All right. The parser, however, doesn't handle it. So let's start making tests for that. Now, mostly, I think we want to basically we want to check that I guess it's a good statement. We got to have a good statement. So I'm gonna find one that's more of a fit, like this one. Too much stuff in here. Okay, so let's test assignment statement. Well, with numbers actually okay. So let's start here. Let's say x equals 42. Well, maybe 25. No, 42. A different number is probably an improvement. Okay. I could say let x equals, but I'm not going to. All right. We parse that. We should get back a line, but it should be an assignment. And the assignment should be variable and expression, and the expression number 42. Okay. Let's see, where's that matching? Nothing. Assignment line equals. Okay, so line 25, assign, maybe we can just say assign variable x gets 42. All right, now parse has no assign, so let's just define that. And it's a statement, so it's up here. Case assign. I guess this is. Do we need the variable? Maybe we just need the x. So let's just do string to expression. Okay. I think that should all look, yeah, there we go. Okay, this should fail because nobody creates, oh, we're going to have a complaint. No, this is the complaint. Okay, down here, we need to handle assign. Assign something to something. We're going to just return assignment and no I. Okay, I'm just trying to get through the, through the errors. Two failures. Well, that's not it. Print is error. I wondered about that one. Okay. Extra characters and okay, that's actually, I believe that's better. Expected start. Why I'm only finding this now. Okay, but the one we care about is this one. We get a skip, yeah, because we don't handle it. Okay, so our parser. This is up at the top. Okay, the statement type and remark print go to if. Well, if we have a variable, we don't even care what it is. Result equals try assignment. Really, that's a reserved word? Assign. Okay. And we don't have an assign method. I'll borrow the function def here. Go to if. Okay. Okay. Let's say name equals, well, oh, these things. It's, let's take the name as a string here, since we have it up here. Variable let name. Okay, so we've got the name. We need to skip over that token. All right, we're going to require an equals. And if you don't get it, you need to get a assignment missing equals sign. Okay. That error we'll define up here. All right, and assuming we have that equal sign, then we do next token. And we're going to get the expression. Okay, so let x equals try expression. Okay, now we got the pieces. So we're going to return a sign with the name and the expression. It's still there. Unknown statement. Okay, that could be a valid error. What does it get? Assignment missing equal sign. Yes, that's true. Okay. That's kind of the same. Oh, we had the same thing at the Lexer level, and now we've affected this level. I think. It really is testing this error case for us. So let's keep that. Assignment assign missing equal sign. And this is assign missing equal sign. Okay. And I think let's pull it down next to our current test. Assignment statement with number. Okay. All right. So I think we're back to. I don't know why I can't clean these. I think there's a way. Product clean test results. Okay. Yeah. Parse simple assignment statement. Let's go ahead and do the let while we're in the ballpark here. Let let's say with let. Well, I don't want to get complicated. Let's just do 2. We trust our expressions to do their thing, so let's keep trusting them. Let a equals 2 should be an assignment. Let a equals 2. And this should fail. What happened? Did it run? I ran the wrong one. Okay. Whew. Skip is not equal to age. Yeah, because we don't even look for a let here. All right. So let's get this case. Isn't that a token? Let keyword. Oh, okay. Oh yeah, we. Let keyword. Okay, so we'll just put in a simple case down here. Yes. Parse. Okay. Okay, so in our let, we come in, we got to get rid of our token. Token. Right, skip over the let. Now we, let's do, well, we're trying to get down to assign. So if, let, variable name, sorry, if case, I like this way there, variable let name equals token. Okay, then we should be able, then we should be at the position where we are just like assign. So we can just return, try assign with name. Otherwise, well, let's throw, I'll just throw this because it's wrong. Okay. Okay, we're just trying to make sure this case comes through. Oh, I'm still messed up. Throw parse error dot. Is that not right? Oh, I didn't wait long enough. Okay. This test should pass. All right, and then we got the error case. Well, which is more like this. Let missing assignment. And I almost think that's really like our end of line thing. Extra characters DOL. No, it's more. Maybe it's something new. I think it's this we want. So if you just say let, we expect errors to be let missing assignment. Okay. And this should fail because nobody references that throw. Okay, and go find our let. Assign. This should be let. Missing assignment. Okay. Now, okay, so we parse everything well. Okay. I'm going to pause here. I think this pattern, give it a string and get a particular error. Let's define a helper for that. And I'm not sure where to put that. Let me put it early. Well, I'll do it down here and then put it up early. Okay, so if let's do check error, and it needs a program string, and it needs a parse error. Okay, so if you fed in this program, then you expect this error. Okay, I think that is true. So this should be the same as check error. And we want to put this here. For to let and this error. Right. Okay, that should still pass. All right, so let's pull this up. And again, this is kind of, I think of it like lemmas in math proofs. You know, we're providing, if you understand this method, you'll make sense of lots of stuff. So let's see who else needs check error. Okay, it's going to be the ones that have errors. Okay, so that one looks the same. Remark. And his error is, and I don't think we need to say parse error because we put it in the type. Okay. Oh, yeah. And you can see we definitely had enough stuff that we should have done this sooner. And really, if you're doing this consistently, the parameterized test is not as critical. I think we'd still benefit from it, but you know, the parameterized test would let us put one body with 10 go to, missing target. 10 let, unexpected expression, whatever. Okay, and here's check expression. Let's move this up as well. And I'm starting to wonder if my expressions should, I don't know, they're kind of becoming a dominant part. Maybe they belong in a separate file. Go to, yeah, okay. Oops. Did I put a comma in here? Yes. Got a typo. All right. And then I don't, do we have a close? I guess I don't see any folding capability here. Is that missing? Code folding, fold. Option command left. Okay. Oh. Can I fold one method? Well, I just want to fold those two. Maybe this is okay for now. All right, run everything. Okay. Okay. So we've got our parser of assignments. Now we need to do our interpreter. All right, let's find interpreter tests. Interpreter should be over here. Yes. Okay. Well, I guess we'll just go down. And if I do that, I expect to see 42. Okay, and what I think it'll do now, I think it'll just print 0 because we always look up variables and find them as 0. Assignment NYI. Okay, yeah, even that. All right. Where's the sign? Evaluate variable. Oops, up here. Step. Yes. Okay, and assign. All right. Well, let's do assign, and let's pull these. Let name, let expression, and we'll pass them in. And we'll define a method down here. Okay, so we've got the expression, we've got the name. We're really just doing this for the side effect, right? So let's let value equal evaluate of expression, and then we want to put it in our variables, numeric variables, sub name equals value. And we're not changing the output at all. Okay. Cannot find output. Oh, I gotta pass it in, don't I? I guess it tends to come in first. Back up to do assign, and we'll pass output. All right, and I believe this should pass. Of course, I'm a notable optimist. Okay. It's supposed to work like that, but doesn't always. Okay. How's that read? Maybe the triple thing would be better. Basic's hard enough to read, right? Okay. Well, we're kind of at a nice place. Let's record this. Interpret assignment statements. All right. Well, to do. Simple assignment let. All right, good. Okay, expressions, subscripts. Yeah, functions. Yeah. Multiple statements on line. That's an interesting one. If relation expr then statements. Yeah, that's another one. Make running right to an output stream. String expressions. Well, okay. I think the subscripts, that's moderately, well, there's stuff going on. Now, one thing is, okay, let's talk about the grammar for subscripts and functions. That'll at least be something. All right. So the way we access now, you just use variable, but if you allow subscripts, then it becomes variable, and this is optional. So you can have left parend, right parend, and expression. That's one-dimensional subscripts. Okay, and really, it's well, it really is expression, and then you might have a comma and another expression, and all this might repeat 0 or more times, followed by that, I think. Let's make sure this looks right to me. My grammar eyes. Okay, so left parend, expression, comma, expression repeated inside the right parend. All that's optional. Yes. That's subscripts, but then you might also have function, and that takes two forms. Oh gosh. Yeah, the list of functions. Yeah, here's the list: abs and so on. Right? It's a little trickier. These reserved words. I guess maybe we should make them reserved words. I don't know. But if you type ABS, right, that's not the variable A followed by BS, much as you might like it to be. It's an actual function name. So let's say function name followed by exactly this. And notice, oh yeah, you can have multiple arguments. You don't have for any of the numeric functions for whatever reason, but you do for these string functions. So to be generic, we would allow it. All right, and our grammar allows any number, but you notice the biggest is 3. And just this mid one. And there's another one. There's factor goes to fn, and then it's just a letter, and then this expression again. Okay. And that one is, there's this def statement. Let's see if we can find the definition of that. Okay. You can define function A, and you can define A through Z of an argument, one argument only. Okay, that's good to know. All right. Equals that. Okay. And then here's the subscript one. You can define a variable A holding 12 things. They call them matrices, regardless of whether it's one or multiple dimensions. Non-dimensioned variables default to 10. So if you just reference A sub, Z sub X, you're working with one that goes, and it goes from 0 to X, which is bizarre. I don't think most basics do. I think the original did. Let's find dim. I believe the original one indexes 0 to n. Oh, this is the OSI one. Okay. Yeah. So if somebody just references one without dimming it, then it defaults to 10. Let's see. So let's look here. I think it's later. Basic. Nope. This manual's a bit all over the place. Well, I saw def. Yeah, so there's also Go sub. We haven't talked about that one yet, but that's another one that's a bit of a, gonna make some challenges. Here's dim. All right. A sub 7 denotes the seventh item in a list called A, and so on. In the old one, the name must be a single letter. Subscripts can be any expression, but must be non-negative. The same letter may not be used to denote both a list and a table. Okay. Somewhere they discuss the indexes. Ew, each list has a subscript running from 0 to 10 inclusive. Okay. I gotta say, I didn't realize this. Now I don't know if it's the same for these micro basics. I'm sure they have something on the. I think I can search this one. Dim. Arrays can have a single dimension. The maximum number of dimensions is 255. Right, but that's not realistic. Oh, this is 0 through 10. Okay, I'm just misremembering. Okay, I mean, so much code is like for I equals 1 to 10 and reference that, and I think they're just ignoring the extra value. But yeah, they reference 0, A sub 0. Okay, and I don't think they require one letter ones. They let any variable name be legit. So the subscripts will have to deal with that. But these functions, let's see. We have those FNAs, FNBs, and so on. Your user-defined functions. Okay. Well, where's that leave us? Okay. We'll ignore this one for now because it's the fn, the def function, and this one maybe we got to worry about variables with dimensions on them. Okay, so subscripts. So the runtime. Okay, so yeah, this is where we're going to get types going on. I'm grabbing a pencil. That won't help you see anything. The we're the type system in BASIC is pretty simple, but it exists. Okay, so the type. I mean, we sort of have integer for line numbers. And so far, we're not using them in arithmetic expressions. Now, the Commodore BASIC does have integer specific variables. We'll ignore that. It's number, aka float. It's string, or it's basically an array of type, I think, is how I want to think of it. So if I have a two-dimensional array, it's an array of something. Okay. And somewhere in here, this limit has to be there. There's knowledge about that. Okay. And, like, how do you keep track of these types, right? And what actually has the type, I think it's the variable. The type is associated with the variable, and you can't, like, use an integer variable to get to the string or something like that. I believe you can't. I don't think you can have an array A and a variable A. I think you have to decide which one it is. Yeah, so this multidimensional array, like, how are we going to represent this stuff? Okay. And where are we going to represent it? More to the point. So in our interpreter, we stuck in the simplest symbol table you could do, right? We put in numeric variables, string to float. Okay. String is the variable name and float is the value. That doesn't handle strings and it doesn't handle arrays. And it doesn't handle types, frankly. Now, I don't know how we're going to make it. Well, I guess my choices are I could have multiple variables. I could have multiple mappings for the variables. So one for numbers, one for strings, one for arrays of certain dimensions. Or I could have values and I got to build the type in there with it somehow. And maybe the value implicitly does. I don't know. But if you say if you say x equals 42, x sub 3 equals 7, something should be going like, hey, wait a minute. We've already got an x. It's been used as an int or as a number, and it's not valid to use it as a array at this point. So the other way around this is string goes to value, and this is just variables. It's my store. Maybe that's a better name. Okay, it's at least a relatively common name in for this kind of thing. But float is not sufficient for that because we can't we can't put floats in sometimes and strings other times, right? We have to have, we'll need a type that's um, above that. Okay, so I think let's see what we said to do. I think really we're going to have to do expression types is going to be the next focus. And whew, that's going to affect all our expressions so far. Because if you said quote 42 quote ABC quote divided by quote DEF times 42, right? It doesn't mean anything. We want to make that conflict come out. Let's see. So where does I think it's got to start? Well, it's got to start down at like almost token level, doesn't it? Or maybe parse level, but um, our tokens, these things know types. Okay, so I think maybe at the parse level, um, expressions, maybe they need types. I mean, I'm confident we can express the type system. It's just how do we tie it in? Does the operator have to? Do we maintain the type as well as the expression? Or does an expression know the type? These imponderables. Well, I guess they aren't quite imponderable because we're pondering them, and it's maybe unanswerables at this moment for me. Well, what I find good to do is say it's time for break because we've gone another hour or so. Let's take another quick break. Well, regular break, 3 minutes, and we'll think about it while we get our drinks or whatever. All right, so I'll see you in about 3 minutes. Hey, welcome back. All right, so the types. Okay, so I feel like I can kind of write the type expressions. I I let's try it. I mean, it's going to be another indirect enum. Indirect enum, and this I don't think. Yeah, we can't use the word type. Well, types and equatable, and let's just say what we said over there, right? We said you could be we'll ignore integer. You could be a float. You could be a string. You could be an array. And I don't know if we want if we need the range in there. Array of types. Okay, so array of float, array of string, array of array. Another way to do this would be an array. Trying to get the dimensions in. Maybe not. Our dimensions are always numeric. It's just how many are there. Okay. Anyway, this would be a sort of small specification of our type system so far, at least implied. You might also have functions. which would look like this function function of arguments goes to return type kind of thing. Although our functions are probably required to be simpler, but this would be a superset of them. And this also implies we could have arrays of functions and stuff like that, and we will block those because this is basic, not C. And not anything else modern. This, like, where does this attach? So I think, I believe we would like to know the type of every expression. Okay, so we don't have enough sophistication to do anything broken around types yet, do we? Because we don't have strings, and we only have one type, numeric. But if we added, maybe we should add simple strings. So if we added string, well, let's start up here. Okay, and this is something I do. I mean, I find happening with when we're implementing things incrementally like this. Like, I'm moving that up because I believe it's going to drive out some problems. It's going to drive out some challenges around type systems. And I could get the type system working for just floats. I mean, we kind of do it implicitly now. And we could sort of hack our way around, strings go in these string variables and numbers go in the number variables. And, where do arrays go? Well, we're going to make array variables 1D and array variables 2D and 3D. It's not very generalized. And it feels like we want some mechanism like this types type to enforce things. Now, well, okay. And okay, at any rate, I think bringing strings in will do that. And the simplest thing would be like print something in quotes. Okay, so a quoted string, and then let us print it, and then work out variables for them. Right now we could say $1 equals 42 and nothing would complain, and that's not right. Maybe we can get far with that kind of problem. Okay. I'm trying to think what would bring out the type stuff. All right. So that kind of does. If you say x equals quote ABC, our assignment statement should say like, hey, my left-hand side's a number, my right-hand side's a string, and those don't mix. And same thing for divide. If you did string divided by string, that operator should go like wait, what? I don't buy it. Now there may be overloaded operators, or maybe you ask operator with type, and there are multiple. There's a string plus and a regular plus, or when they both can do it. Um, I'm just not quite seeing like expressions. The types can change. We don't do that. We don't have booleans like our relational operators return numbers, so that's fine. But we can say $A equal B dollar. If $A equals B dollar, then do this. That seems legit. If $A equals 7, do this. That seems a little like, are you going to automatically convert it, or what's the rule? Yeah, so maybe that's a good one. So let's take the slash operator. If you parse at parse time, you're building that, and you've got two strings. That slash operator should balk. Because it looks at its left expression and says, what's your type? And it looks at the right expression and says, what's your type? And they both should be expressing that. Okay. Do I need a string token to make this go? Make this be a problem? I don't think I do, because I have variables that have a type. And we know the type of a number is always float. There's no choice on that. But the type of our variable could be float or string. And the variable embeds that in its name. Now, it doesn't tell us about arrays. How would we know this? I guess it does. I mean, if we parsed it, we would know it's a sub-expression. Okay. I think variables should know their types. Maybe that's a step we can take. If you reference a variable, we should know its type. Okay. Let's see. How are we going to do that? Okay. If a variable knows its type, and we do an assignment, A equals B dollar, that should be illegal. We got the variable on the left, A, and the variable on the right, B dollar. Okay, I think we can do this we can hold off on the string expressions momentarily, because we have this, we have the variable that can take different types, and we can tell those types right now. And I think what I'm saying is a variable should know its type, and the parser should enforce that on the assignment. Okay. Assign. Okay, so we have the name. Well, actually, we have the token with the name. Yeah, let's make a test where I guess this. Let's see what happens. Test mix. Well, assign string to number fails. Okay. If you say, oh, let's get this. Yeah, so check error. A equals $B. Then we expect to get the error. Assignment type mismatch for the sake of argument. And parser defines that. Okay. This should fail. Okay. And the reason is it should just be an assignment. Oh, 17. This is definitely why we run tests first. Because we want to make sure it fails for the right reason. Nothing is not equal to that. We expected an error. We did not get one, is what that's saying. Okay, so let's see what we can do. Parser. And this is where I think I'm going to kind of backfill some stuff. Okay, we got our assignment. Let's go to this one. I think the name, the token. Right. I think variables should tell you their type. Now we picked off the name, but I think that's probably we don't. I think okay. I think our variables need a type as well. Whether that comes in. All right, parse. Let's see, when I add this, it's going to like blow up all over the place. Okay, let's do a build. Okay. Variable let name. Well, we ignored the type. Okay. Cannot convert value of type. Same thing there. I guess that's all interpreter. Oh, this is parser. Right. Return variable missing the type. Okay. That doesn't look like it's impossible to do. I mean, four errors I can live with, I guess. Missing argument. Okay. We'll take the test out of the picture for a minute while we pretend we've always put types here. So check expression x variable. Well, its type should be dot float. Okay, because that's what a variable like that is. Didn't we check all the variables? I thought we parsed $. That's the first one. Oh, man. Okay. Okay, so I'm saying check expression variable should have type float. All right. And let's see, the parser. All right. His name of type string. Well, where's variable? The caller. Okay. If variable let namelet types, which from I think parse has types now. Okay, I think we're past it. All right. We'll ignore this for a minute. That's parser, and I just ignored that. So deprecated. Okay, that's fine. I think that's just hasn't caught up. Okay, let's do a build. Pattern with associated variables does not match enum case variable. Why not? That's token. Let's make sure our tokenizer is good with this. Token lexer. Sorry, token is this variable string. Maybe that case is not the right one. Right, these are tokens, so this does not have that. This does not have that. And variable name is returning expression. He needs a types. Okay, so that's the sticky point. Okay. Well, let the type equal if name ends with $, it goes to string else float. Cannot incur base with the type of types. Value of type string has no ends with. Really? name dot. Well, I could do last. I'm pretty sure I saw ends with in my list of possible things. Really? Okay. Name dot last. Okay. So this should work for everybody so far. What I've done is I've made sure that when I create the variable parse structure, the variable knows its type. Okay, so now let's go back to this and run. Okay, and the parser should complain about the assignment. Okay, so where's assign is up here. Okay. So it keeps track of the name. I really think it should keep track of the type as well. So let's go find assign. I'm kind of thinking we're not going to pass that name in anymore. We're going to do this kind of thing. Assign. I'm going to take out name. Take out name. Should be 2 complaints. At least 2. Well. Variable. This is the token, so it's got one thing. And assign. Well, now it doesn't know where it is. Okay. Let's let now we know this must be the right, do we? Oh, it's only the name so far. Okay. It's the token. Well, I'm confusing myself. I think because this variable down here, that's from expression. Okay. Balling myself up with these names being the types matching so much. Okay, so we get the variable name, try assign name. Okay. If case variable let name, I think we're just going to say just assign. Is that right? Well, okay, we've read the token. We're only going to do this if it's a variable. Yes. Okay. Return try assign with no name. Okay. Because you go in with the token you got. All right. Now this there's a swift way to do this. What is it? It's I can't remember. It's require. If this is not the case, like we wouldn't be in here because we already know it's a variable. I'm just trying to get this out. I think another way to do that is can I just say let I think there's a way to get this as a tuple out. Yeah, there's let case, right? Where's my Swift let case? If case let equals inner if. Well, I can do case let, yeah. If case let or this, I usually write it this way, but guard is the word I was thinking of. Okay, yeah, let's try guard. Guard case let this else, and it's really, I don't know, it can't happen. Okay. This is one of these things that drives me nuts. It should be easier to just pull out a field when you know you've got the right variable type, but I think this is what it can do. All right. In any case, I have the name from the variable. I want to say let left type equal type for name. Okay. And type for name of type string, and it returns a boolean. Sorry, it returns a typed, and that's this expression down here. I don't need to do a sign if all I'm going to do is return it. Okay. If name.last is, well, let's flip it forward. Oh, if it equals $, then string else float. Okay. Left type equals type for name. Good. Now, the expression. So what I want to enforce is I want to enforce left type is right type. Okay. And maybe that's where we'll pick up. I don't think that's a one-line thing to get that in expression. Given an expression, can I figure out its type? Well, I think our variable can tell you. I mean, we're going to have a variable. I don't want to do the type, though. I want to just ask it. Okay, well, that makes it a good place. We got a failing test. I don't think we have any syntax errors. Yeah, not really. Okay. And we got something we got to pick up on tomorrow. So I got to enforce this. I've got the left type. I know it's either string or float, basically. And I've got to add a type. So somehow I get a type for expression or something like that. Type for name is one thing. Type for expression, if it doesn't embed it, I got to figure it out somehow. So let write type equal type for Okay. So somehow the expression knows it, whether it's directly or indirectly. It could be a recursive computation or whatever. Yeah. All right. So we'll pick up there tomorrow. Like I said, odds are good. I won't be, well, odds are almost sure I won't be here at 9, but 9:45 or 10 is probably pretty reasonable. So a little late start. And thanks for joining me today, and I hope to catch you in the future. Take care. Bye-bye.